In this video, I will teach you about basic differentiation rules. But to understand how awesome this is, I first need to remind you of what I taught you in the previous video when I showed you how to use the definition of derivative to come up with a formula that would give you the slope of a curve at any point. This process was called differentiation, and it was often very tedious and cumbersome, and it took a long time, and it looked like this. But today it is my privilege and pleasure to teach you some shortcuts that will often allow you to do the same thing in seconds. The first rule I want you to memorize is that the derivative of a constant is 0. Now, this makes sense if you think about the fact that the derivative tells us the slope of a curve at a point. So picture a constant function. Let's say f of x equals 2. All right, so here we are at 2. A constant function would simply be a horizontal line. All right, this is what the function f of x equals 2 would look like. And what's the slope of a horizontal line? 0. Now, similarly, the derivative of x is equal to 1. That also makes sense if you think about the fact that the derivative tells us the slope of the curve at a point. And if we graphed the function f of x is equal to x, in other words, this is the line y equals x. That graph goes up 1 over 1 at a 45-degree angle. That's what the line y equals x looks like. And of course, the slope is 1. Of course, these examples are really simple, but it gives us a chance to practice our notation. So if y is equal to 7, then dy dx is equal to 0. Remember that dy dx is one way of writing the derivative. If f of x is equal to pi, then f prime of x is equal to, again, 0. Remember that f prime is another way of saying the derivative of f. If y equals x, then y prime is equal to 1. The derivative of x is 1, and writing y prime is another way of expressing the derivative. Next, we have the power rule, which says that the derivative of x to the n power is equal to n times x to the n minus 1 power. In other words, we can take the exponent, bring it to the front, and reduce it by 1, and that will be the derivative. So if f of x is equal to x to the third power, and we want to find the derivative, we're going to bring the 3 to the front, so we'll have 3x, and then we reduce the exponent by 1, which gives us 3x squared, and that's the derivative. All right, what about something like this? G of x is equal to the cube root of x. That doesn't seem to quite fit the pattern of x to the n power. Or does it? Isn't this the same thing as having g of x equals x to the 1/3 power? All right, get that back to the front of your mind. A cube root is the same thing as the 1/3 power. Square root is the same thing as the 1/2 power, etc. So now we can just use the power rule. So g prime will equal, we're going to take the 1/3 power and bring it to the front. And now we have to take 1/3 and subtract 1 from it. So remember, off to the side here, if I do 1/3 minus 1, that's the same thing as 1/3 minus 3 over 3, which is really negative 2/3. So if I take 1/3 and I subtract 1 from it, I'm going to get negative 2/3. So this will be the derivative. So it's very often that our first step is to rewrite the function so that it fits the pattern x to the n power. How can I rewrite this function so that it fits the pattern x to the n power? Well, 1 over x squared will be the same thing as x to the negative 2 power. And now we can just use the power rule. So y prime, the derivative, should equal negative 2x. I've brought the negative 2 to the front, so now I need to subtract 1. Negative 2 minus 1 is negative 3. So this is y prime, the derivative of function y. Next, we have the constant multiple rule, which tells us that if we have the derivative of a function that's being multiplied by a constant, we can pull that constant out front and then take the derivative first and then just multiply by the constant afterwards. So looking at example 3, if I want to find the derivative y prime, I see the constant there. I can just leave the constant in front and go ahead and take the derivative of x to the 3rd power. Using the power rule, we bring the 3 to the front and then reduce the exponent by 1. And then afterwards, we multiply by the constant. So y prime will equal 15x squared. Take a look at part B. Let's go ahead and rewrite this so we can use the power rule. So this would be the same thing as y equals 2 times 1 over x. And then this would be the same thing as having 2 times x to the negative 1 power. So now we can go ahead and find the derivative. First of all, the constant. Remember that the constant is just going to stay where it is. We're just going to leave it alone, and then we'll do the power rule on the variable and the power. For the power rule, we will take the negative 1 and put it in the front, and then we reduce the power by 1. Negative 2 minus 1, negative 1 minus 1 is negative 2. And then we can multiply by the constant at the end. I meant to say y prime when I did that. So y prime is going to equal negative 2x to the negative 2 power. When we get comfortable with this, we're going to skip some of these steps, but for now I'm showing every detail because we're just learning. In general, we are not allowed to leave an expression with negative exponents in it for the final answer. So let's go ahead and rewrite that. With the negative exponent, we're going to drop this down into the denominator, and our final answer will be negative 2 over x squared. When we drop the x to the negative 2 power down to the denominator, it becomes a positive 2 power. So this would be the final answer. Part C, f at t equals 4t squared over 5. Well, let's rewrite this a little bit. So f at t equals, we can take this 4/5 and write it as a single constant in the front. So this would be the same thing as having 4/5 times t squared. So now we're ready to take the derivative. So f prime of t is going to equal, the constant, we're going to leave that alone. And write 4/5, just leave that alone. And now we'll do the power rule. Take the 2, put that in the front, and then reduce the exponent by 1. Well, that'll just leave a 1, which we don't really need to put. So we have this. And for the final answer, we'll just go ahead and multiply by the constant. And remember, 2 is the same thing as 2 over 1. So when we multiply straight across, we're going to have 8 over 5. So this would be the final answer. You also could write it as 8t over 5, but I think either one is acceptable. Part D, y equals 2 radical x. First, let's do a little bit of rewriting. The square root of x is the same thing as x to the 1/2 power. So now we can go ahead and find the derivative. First, the constant, we're just going to leave that alone in the front. Now the power rule, we're going to move that exponent to the front. So this will become 1/2 x. And now we have to subtract 1 from the exponent. So off to the side over here, if I have 1/2 minus 1, of course that's 1/2 minus 2 over 2. That's going to be negative 1/2. So I'm going to have x to the negative 1/2 power. So now I can go ahead and multiply by the constant. 2 times 1/2 is 1. And I really don't need to put anything. So it's like these just cancel each other out. So, I'm going to show this extra step. So I have x to the 1/2 power because those 2's cancel each other out. Don't leave it like this. So we will have y prime equals, because of the negative exponent, that means we need to drop this down to the denominator. So we're going to have 1 over x to the positive 1/2 power. Once we drop it down, the power becomes positive. But don't leave it like this either. Remember, in the beginning, we had the square root of x. We changed it to the 1/2 power. Now we need to change it back. So the final answer would be y prime is equal to 1 over the square root of x. Part E, y equals 1 over 2 times the cube root of x squared. A little side note here, fractional exponents. If I have x to the p over r power, I picked these variables on purpose because a fractional exponent is in the form power over root. So I could rewrite this, and so the root would go here, and then the power goes here. And then that's a two-way street. So I'm just going to reverse this for this part of the function right here. So as I recopy it, I'm going to have y equals 1 over 2 times, but fractional power. Remember, power over root. 2 is the power, 3 is the root. So this would be the same thing as the 2/3 power. Now, because this is in the denominator, this is actually going to be the same thing as having x to the negative 2/3 power. So this would be the same thing as having 1/2 times x to the negative 2/3 power. All right, I sort of moved it out of the denominator and made it a negative. So now I can use my rules. Y prime is going to equal, first I leave the 1/2 alone. Now I'm going to use the power rule by taking the exponent and putting that into the front. So that's going to give me negative 2/3 x. But then the new power, I need to subtract 1 from this. So look at that denominator. So basically, if subtracting 1 would be the same thing as subtracting 3 over 3. So, negative 2 minus 3 is negative 5. So this would be negative 5/3, the negative 5/3 power. All right, now I can go ahead and multiply these together. So I'm going to have y prime is equal to negative, negative 2/6, but this is going to reduce down to 1/3. All right, so negative 1/3 x to the negative 5/3 power. I can't leave my answer with a negative power, so I'm going to go ahead and drop this down into the denominator and make it positive. So this will be y prime is equal to negative. And okay, so here's my negative 1/3. But this x to the negative 5/3 power will now be joining into the denominator, and it'll be x to the 5/3 power. I think I'm going to need a little bit more room. Okay, so here's my x to the 5/3 power, and there's the 3. All right, now in the beginning, we did not have any fractional exponents. We had a root. So for the final answer, let's turn this back into a root. So y prime is going to equal negative 1 over 3 times. And remember, this fractional exponent is in the form power over root. So the 3 is the cube root. And the 5 is the 5th power. So this would be our final answer. Let's look at one more example before we move on to the final rule. So I can easily rewrite this as y equals negative 3 over 2 times x. So now I can use my constant rule and write y prime is equal to, and so the constant rule says we'll just bring down the constant unchanged and we'll multiply by that later. And then we had that rule where when we take the derivative of x, that's just going to be 1. So obviously multiplying by 1 is not going to change anything, so the final answer will be negative 3 over 2. In fact, this is going to come up so much that you might want to think of it as a new rule. The derivative of a constant times x is just the constant. So here we had a constant times x, the derivative is just the constant. The last rule I want to share in this video is called the sum and difference rule. And it basically says if I want to find the derivative of the sum of two functions or the difference of two functions, I can take the derivative of each function separately and then add or subtract. I should make this a plus or minus. The sum and difference rule is awesome because it allows me to now take the derivative of any polynomial really easily. So f prime of x will equal. So again, the sum and difference rule just tells me I can take the derivative of each term separately. So the derivative of x to the 3rd power, using the power rule, I pull that 3 to the front and reduce the power by 1. Boom, that term's done. Now I'm going to take the derivative of negative 4x. Remember that if you have the derivative of a constant times x, it's just the constant. So this will just become negative 4. And if you take the derivative of a constant, that is 0. So we write nothing, and this is the final answer. Feel free to skip this next step because I'm sure you could do it in your head. I'm just going to take this 2, and there's an invisible 1 in front of here, so I'm going to bring this out in the front as a constant of negative 1/2 x to the 4th power. And the rest I'm going to leave the same for now. So according to the sum and difference rule, I can easily take the derivative by taking the derivative of each term separately. So the first term, the constant rule, we keep the constant the same, just bring that down. And then we'll do the power rule, move the 4 to the front and reduce the power by 1. And now moving on to this second term, the constant of 3 stays. Now the power rule, I bring the 3 to the front and reduce the power by 1. Don't forget that when you take the derivative of a constant times x, the derivative will simply be the constant. So that means that g prime of x is going to be, well, let's see, negative 1/2 times 4 is negative 2, x to the third power plus 9x squared minus 2. And that's the final answer. So here comes the last example. Let's do the rewriting stage. So y equals, we can take this x and write it separately underneath each term. So this would be the same thing as 3x squared over x minus x over x plus 1 over x. Now this would be the same thing as, well, if we divide by x, that's going to cancel out one of the x's and just leave 3x. X divided by x will be 1. And then, you know what, let's go ahead and write this, rewrite this term so we can use the power rule. This would be the same thing as x to the negative 1 power. Now we are ready to find the derivative y prime. So remember that the derivative of a constant times x will just be the constant. The derivative of a constant is 0, so this will just be gone. And then for the last term, we're going to use the power rule. So the power rule says we can take that exponent and put it out to the front. All right, so there's going to be that negative 1 out in the front. And then we reduce the exponent by 1. So that's going to make negative 2. All right, obviously the 1 really isn't doing anything, so we just have 3 minus x to the negative 2 power. So let us not leave a negative exponent. Instead, we will write 1 over x squared. And this would be the final answer. Now, it turns out that a big part of calculus is memorizing rules like this. I suggest that you have a set of notes somewhere where you keep track of all the things in the unit that you need to memorize. And here's what you should have so far. We learned that the derivative of a constant is always 0. The derivative of x is equal to 1. If you have the derivative of a constant times x, it'll just be the constant. If you have the derivative of a constant times a function, you can pull the constant out front and then take the derivative of the function. We love the power rule, which told us that we can take the exponent, put it in the front, and then reduce the power by 1. The sum and difference rule allows us to take the derivative of each part of a sum separately or difference. Oh, there should be a minus right here. And finally, we get to today's new rule. The derivative of sine is cosine, and the derivative of cosine is opposite of sine, or negative sine. Problem number 1, y equals 2 sine x. We're going to find the derivative. So y prime equals, remember when there's a constant, we can just keep the constant out front and then take the derivative of the function. And we just learned that the derivative of sine is cosine. So this will be cosine x. And that would be the answer to number 1. So problem number 2, y equals sine x over 2. If I want to find the derivative of this, my first step is to rewrite this as 1/2 times the sine of x. So now I can do the exact same thing that I did on problem number 1. Y prime, I will keep the constant in the front unchanged and then take the derivative of sine of x, which is cosine x. If I really wanted to, I could put it back in a similar form to what I had and write cosine x over 2 for the final answer. Number 3, y equals x plus cosine x. We learned by the sum and difference rule that we can take the derivative of each part separately. So this is going to be super easy. Y prime equals the derivative of x is 1. That's just a rule that we memorized. And now the derivative of cosine is negative sine. And that's all there is to problem number 3. All right, one more example. F of x is equal to cosine x minus pi over 3 times sine of x. So we'll be finding the derivative f prime of x, and we can take the derivative of each part separately. So let's start with the derivative of cosine, which we've learned is negative sine. Now we'll take the derivative of the minus pi over 3 sine x part. We've learned that when there's a constant in the front, you can just bring that constant down, unchanged, and then take the derivative of the function. So the derivative of sine x is simply cosine x. And that's the final answer.